Hello friend, in this lecture we will discuss about memory organization of C program. So when we type a command gcc, let's say file name is p1.c, gcc p1.c -o p1, it will compile the program, it will generate the binary file name is p1. Okay, and when we type .p1, then hit enter, then p1 file load into RAM. Okay, when we compile a program, that time it will store in hard disk, and when we hit this file as a ./p1, it will load into RAM. See, when we compile file, that time it generate file p1, that time it allocate memory in hard disk, it consumes some memory. Same way, when we hit the p1 file and load it, when it load in the RAM, it must be consume some memory in RAM also. Okay, when this program load into RAM, it consumes some memory in RAM also. That memory has a four section. One is section is called heap section, stack section, data section, and code section. We'll see step by step in practical also. Okay, so these are the memory allocation of C program. Like from lower address to higher address, if we go first is text section. Text section is nothing but code section. This what we are what I have mentioned here in code section. Then heap section, data section. Data section again modify divide into two part: initialized data and uninitialized data, BSS. Then heap section and stack section. Heap section is upgrowing memory and stack section is downgrowing memory. Okay, heap section is used for dynamic memory and sheet section is for local variable access or declaration. We will see in detail stack section. So we are so far we discussed for section of binary when it load in the RAM, stack, heap, code, and data. So what is the use of stack section? Stack section consists all local variable. Whatever local variable we declare, like it will like auto variable, whatever we declare is stored in the stack section. Function return value. When one function call from another function, the return value, it must have a return value, right? So return value is stored in the stack section. Formal argument. Let's say you are calling one function, it has a arguments from another function, so that argument also store in stack section. And fourth one is stack section size is depend on the OS. For particular Linux operating system, 8 MB is reserved. Okay, so let's take some example so we can understand better way. See, I'm writing one small program p1.c as include stdio.h integer main, simply print up hello world, hello world. Okay, so we'll try all the command. When we gcc p1.c -o p1, when we hit, it will generate p1 file. So see, it has generated p1 file. The size is this much, and it must be, it is allocated in data hard disk. Okay, see, when we compile the file p1.c, it generate binary p1 and size allocated in its. When we load like this, it will load in RAM, and RAM memory allocate till program execution is, till program is being executed. Okay, so see p1. Okay, no issue. This third one, this text section, all we cannot see, but this we can discuss. So this local variable we can it store in text section. This formal argument, what is mean formal argument? Formal argument means, let's say this is integer abc, integer a, integer b. Okay, we are calling one function from this one, this main function. We are calling one ABC function from this 10 20. Okay, so this is called, this A and B is called formal argument of function. This is also again auto, this is also again local variable is stored in the stack section. Okay, okay. Heap section, heap section is useful for dynamic memory allocation. Like I hope you may have heard, like malloc, calloc, realloc, pre, those are useful for dynamic memory allocation in free. So this dynamic memory allocated in stack section, this section is this section has no fixed size, it is upgrowing toward the stack section size. See, this already we discussed, right? This heap section has a no fixed size, it upgrow toward the stack section. Data section, data section consists static variable, global variable, as well as function symbol. Okay, suppose we are defining two function, that function symbol, function name stored in a data section. Data section size is not fixed, it depends on the user program. How many global variable, how many static variable user application user has a defined in application. It's depend on the user program. Stacks code section. Code section is consist of program code. All instruction of program stored in the code section. Again, code section size is depend on the user program, because how much big is code is depend on the user program. See, we have generated p1.file here, executable file. See, this p1 dot, when this p1 file is in hard disk, it is a two section. It has a two section, data section and code section. When this p1 file in hard disk means not loaded in RAM, that time it has a two section, data section and code section. Code section is, code section store instruction of the program, and data section store global static variable and function symbol. When this program p1 load into RAM, it consists four section: code section, data section, stack section, and heap section. Okay, and for your information, CPU fetch instruction from code section. Okay, this is all for this lecture. I hope you find well. If you find something good in this lecture, please like, subscribe my channel, and share this video with your friend. Thank you.